This presentation will be over the protocol SSH, which stands for Secure Shell Protocol. My name is jsaladin, and this is for the class of System Security 2. Above in the middle, you can see a picture that I included of the SSH client and the SSH server. What is SSH, you may ask? Well, it is a network communication protocol which allows two computers to effectively communicate. It is also an abbreviation for Secure Shell. The communication between the two computers is always encrypted, making sure that everything is always secure at all times. Most frequently used for logins and performing operations on remote computers. It is also suitable for use even on unsecure networks. To your right, you can see a picture of what it looks like when information is encrypted and transferred from a client to a server or vice versa. Some benefits of using SSH protocol, which is secure shell. Encryption utilization to always make sure that the information transfer between the server and the person is always secured. You can execute shell commands on a remote computer. It removes the need to be right in front of an actual real-life computer. You can move freely in your hosting account file structure. Malicious attackers are unable to access your confidential information nor passwords. To your right, you can see a picture of kind of like a diagram. This is kind of an example of a process that SSH does. First, the SSH server listens to a particular TCP port. Then SSH client initiates the SSH connection. It accepts one protocol and version from the protocols and versions offered by the server. The server sends its public key to the client. The client then verifies the public key, and then both the server and the client negotiate a session key. The server then authenticates the user. Some hardening recommendations for SSH, which stands for Secure Shell Server, is that you can disable empty passwords that are unnecessary. In other words, if those users try to use SSH, they won't need passwords for accessing the server via SSH as well. That is a security risk. You should always avoid using empty passwords. You can do so by going to the /etc/ssh/sshd_config file, and then make sure to set it always as permit empty passwords option to no. This makes sure that it is not a risk anymore. You can also change default SSH ports. The default port for SSH is always going to be 22, and a variety of the attack scripts check are written around this port only. Changing the default SSH port will add additional security because the variety of attacks may come to an end and may be reduced for risk. You can search for the information of the port if you need to by putting in the command port 2345. Another hardening recommendation is that you can disable root login via SSH. Using a server as root itself should always be not allowed regardless. It is always risky and it leaves no audit trail. If you have sudo users added, you should use that sudo user to access the server via SSH. Do not use root and try and stray away from it at all costs. To disable the root, you can just input the command permit root login no. Another hardening recommendation is you can utilize proper configuration of the idle timeout interval. The idle timeout interval basically is the amount of time of SSH connection that can remain active without any activity, such as idle concessions, or also a security risk. You can do so by inputting client alive interval, and then, for example, if you want to change it to 500 as a timeout interval, then just put 500 right there. After this, the SSH server will send a response to the client, and if it doesn't get anything back, the connection will close out. You will then be logged out, which is really good. You can also control how many times the message is sent before a disconnection is performed. To do this, you would put client alive count max. And then, for example, you can put, like, let's say, if you want to send a message 5 times, then just put 5 afterwards. One last hardening recommendation, but not least, you can disable SSH Protocol 1. So in other words, basically, that is a good method in order for a hardening recommendation. This is if you are using mostly an older Linux computer. Some older versions might still have it available, but this protocol has just been in general known for all of its vulnerabilities and should be avoided at all costs for the maximum security. Newer versions automatically have Protocol 2 enabled, so you don't even have to worry. If you want to double check, just input the command Protocol 2. There are more hardening recommendations that I didn't mention, and those include disabling X11 forwarding, mitigating brute force attacks automatically, and then you can do this by using a security tool such as fail2ban. The parameters can always be configured, which is really good as well. If you want to Google instructions on that, you can. And then two-factor authentication with SSH is also one very good hardening recommendation. There are many more to name, but these are just a few that are still very important. Using OpenSSH. SSH basically is a power collection of tools to assist in the remote transfer of information. It is basically the free version of the SSH Secure Shell Protocol family. Actively listening for client connections from any client tools, it's what it does best, and then effectively replaces legacy tools. To your right, you can find a picture of what the logo for OpenSSH looks like. Here I attached a diagram of kind of what the process for SSH client and SSH server looks like in the process of the transfer of information. Number 1, the client initiates the connection by contacting the server. Then the server sends the server public key. Then they negotiate parameters and open a secure channel. And then user log into a server host operating system. And then this is the works cited page. Some other things that I did not add, but I would like to mention, just some honorable mentions, is that the SSH has many advantages, such as IP source routing, DNS spoofing, and data manipulation. Also, eavesdropping or sniffing of the transmitted data, and IP address spoofing as well. For IP source routing, it can also be used by malicious users to make a machine think it's talking to a different one. For DNS spoofing, basically that is a type of a hacking attack where data is inserted into a DNS server's cache database, which causes the name server to return an incorrect IP address, so it can divert traffic to another computing device. And then, of course, data manipulation, you can use that. Data enters a sort of gateway or checkpoint, basically, and then eavesdropping, an attacker can watch the data that goes through, collecting confidential information, which you should always be careful. And yes, this is my works cited page, and thank you for listening to my presentation.